Okay, let's talk about the calculators. I know many of you in chemistry, you have used logs with calculating pH and whatnot. You use the calculator. Okay, a common log, that's what it's called, the common log is base 10. So the button on your calculator that says log is base 10, meaning 10 to what power is going to give me this number. Okay, so, and if you ever see it on paper where they don't put a little subscript here showing you the base, then it is base 10. Hence this problem here, log of 12. What's the log of 12? Well, you use your calculator to do that. It's base 10. The other one is the natural log, which I kind of talked about when I introduced the number e, because a natural log is base e. And on your calculators, it's ln, not nl. And I think I mentioned that before. It's because it's a logarithm with a natural base. That's why they use ln. Okay. So we use the calculator to do these evaluations, and it's strictly you just press log and then 12 and press enter. Log of 12 is 1.079. Okay. And when they're giving you a log and it gives you some crazy decimal, don't round it off to the tenths. Take it out to a few decimal places. You will see in your book that they're going to use about 4 decimal places. Okay. Find the log of 0.75, or the natural log I should say. This is negative 0.2877. Okay, round it off, of course. Alright, this is something you're going to like. The change of base formula. You can, one property of logs, you can change the base. So if you don't know what the log base 2 of 12 is, you can change the base and get a decimal approximation for that. Okay? This is, okay, log base c of a is equal to the log base b of a divided by the log base b of c. We're changing the base to base b. Okay? The only time I ever use this change of base formula is when I want to use my calculator to help me evaluate the log, because it's not an easy, it's not like I'm asking log base 3 of 27. You know, it's log base 3 of 14. Okay, log base 3 of 14, I would definitely use the change of base formula to find the answer to. Okay, so log base c of a, we can change it to a common log. It's going to equal the log of a divided by the log of c, or the natural log of a divided by the natural log of c. It's going to give you the same answer no matter what you change that base to. So let's use it. Evaluate using the change of base formula. Okay. Log base 5 of 8. Okay, I don't know what power I take 5 to get 8 for my answer. So I'm going to use the change of base formula and put it into a common log or a natural log and get the answer that way. Okay. So using the change of base formula and the common log, I'm going to change it to the log of 8 divided by the log of 5. Okay? And when you do that, you use your calculator. Now be careful, because my calculators will open parentheses. You got to make sure you close them. And the answer is 1.2920. Okay, that's taken out to the 4th decimal place. If you check it, to check your answers, you are going to take 5 to the 1.2920 power. Take 5 to that power, and I bet you it's 8. Or it's going to be very close to 8. Okay? Now this one, log of 9, we want log base 26 of 9, so what we're going to do is we're going to take the log of 9 and divide it by the log of 26. And when we do that, we're going to get 0.671. And of course, you know, you can check your answers. Okay? Not with that. Take 26 to this power, and it's going to be very close to 9. Just like that, to be very close to 8. Okay? The more decimal places we have, the closer we'll be. Okay, that's why I don't like rounding. Graphing, I figured we needed another practice at graphing this inequality. Okay? Graphing the log of x minus 2. Okay? This is considered a common log, which you could technically just put into your calculator, but you know, I'm a firm believer in doing things the other way. So, to graph it, since it's a logarithm, we need to get some points by converting to its inverse, its exponential inverse. 10 to the x equals y is its exponential inverse. So we use that to get some points. Okay, using -1, 0, and 1, 10 to the negative first power is 1/10, 10 to the 0 is 1, 10 to the first is 10. Now, the log of x is going to be the switch of these two. So you take these and you just flip them over. Now our x's are here and our y's are here. What this does is that is going to shift our graph 2 units to the right. So instead of our point being at 1/10 negative 1, it's going to be at 2 1/10 negative 1. Instead of it being at 1, 0, it's going to be at 3, 0. And instead of it being at 10, 1, it's going to be at 12, 1. Okay. So here is our graph of the log of x minus 2. Okay. Same is true whether it's log base 2. If it's log base 2, you definitely cannot use a calculator to do it. You have to do it this way. Okay. This has a vertical asymptote at, or your domain is going to be x is greater than 2. Your range is going to be all real numbers. Next, this is a vocabulary term more so than anything. I saw it in your book. I've seen it on the assignment, the problems I've given you. I've seen the term on your exam, so you need to know what it means. Okay? The antilog. Okay? If the log of x equals a, then x equals the antilog of a, which basically means 10 to the a power equals x. Okay? Antilog is for logs of the common base, base 10. Okay, that's what that one means. And you'll use your calculator. There's a 10 to the x key. You've got the log on the calculator, and then the shift of the log is 10 to the x power. I think it says, not a, 10 to the x power. Just like the natural log, and on a shift of that, it's e to the x power. Okay? Solving by using the graphing calculator. Okay? What we're going to do is we're going to graph these two separate equations in y1 and y2 in our graphing calculators. Then we're going to zoom in or zoom out or whatever we need to do to find the point of intersection between these two graphs. Once you find the point of intersection, then you're going to use the calculator to go through the whole process of finding that exact point. So what I have done is I have entered the two equations into y1 and y2, and when we graph it at our standard screen, it's very, very, very hard to tell if there's anything going on. So what we need to do is we need to zoom in. I see everything is above 0, so I'm going to change my window to, for my X-Men I don't need to know what's going on over here because both of these are an exponential growth. So I know somewhere up really high is where I'm going to find the point of intersection. My Y minimum, I don't really need to know where that is. I'm going to change my Y maximum to like 150. You can do this in stages if you need to. I have already done this problem a minute ago, so I know where to go to with it. If I didn't, well, you would see what I would do, and that's just trial and error until I find it. When you hit graph, it's still kind of hard to see. You can see the graphs kind of run together right there. So, and that's between 1 and 2. So now what I'm going to do is I'm going to change my graph so I only get this portion. I'm going to change the window. I want between 1 and 2 on my x-axis, and scale doesn't matter. Then for my y minimum, I'm going to make it a minimum of 100 and a maximum of 150. So I'm changing it, so I'm only looking at where I think they intersect. Okay, there's y1. Here comes y2. There's y2. It looks like they're intersecting right in there. So now what I'm going to do is I'm going to hit second calculate, which is on the trace. Number 5 down is intersect. So I'm going to press 5. It's going to say what curve, first curve. Yep, that one. Yep, that one. And my guess, sure. And as you look, you can see the x-coordinate of the point of intersection is about 1.5286, and then 137.0, blah, blah, blah. So we would just round that off, not to the nearest whole number, because we don't ever want to be that broad. The point of intersection, or the solution, is about 1.529. And the y-coordinate is 137.07.